What if, the absolute best way to fix a broken leaky system isn't to patch the hole, but to actually just make that hole permanent?
Right, which sounds completely counterintuitive at first.
It really does. But welcome to today's deep dive. We are jumping straight into a single, just really fascinating source today,
Yeah, it's a journal entry dated July 4th, 2026,
titled Notes on Fishkeeping, Part 282.
by an author named Ang.
Exactly. And our mission today is to explore how a highly frustrating, everyday problem like a literal water leak sparked this totally unexpected engineering epiphany.
And more importantly, how flipping your perspective on structural failures can entirely change the way you manage the, draining leaky problems in your own life.
Yes, because that is where the real value is for you listening right now. So let's set the baseline here.
Well, it fundamentally challenges how we think about boundaries and control. I mean, in systems design, we just naturally assume a flaw is a liability.
Right, a bug in the code.
Exactly. But sometimes the very defect causing you a headache is actually a mechanism just waiting to be utilized. The flaw is the solution hiding in plain sight.
Okay, let's unpack this because we really have to start with the physical reality of what Ang is dealing with to understand the scope of this epiphany.
We need to look at the literal situation first, yeah.
Right, so we have an outdoor pond. But, this isn't some architectural concrete koi pond. It's an EPS-foam box.
Expanded polystyrene.
Yeah. It's essentially a heavy-duty, repurposed shipping cooler being used as an aquatic habitat. And this foam box has developed a small leak right at the bottom.
Which is exactly what happens when you repurpose materials like EPS foam for long-term hydrostatic loads.
It just degrades.
It does. Over time, the material's physical integrity compromises. The universe is essentially pulling the water out of that box through gravity.
Water is persistently, gradually dripping out. And it's like trying to keep a leaky tire inflated or, I don't know, a cracked bucket full. The baseline human reaction is just pure annoyance.
Oh, absolutely, because it creates a very specific kind of burden.
Yeah. The text notes that Ang has to manually top up the pond from time to time just to maintain the original water level. And we have to talk about what that actually means for a person.
It's a massive maintenance burden.
Right, because it's not just the physical act of carrying a pitcher of water. It's the concept of system entropy.
Yes.
A closed system naturally degrades, and it requires human energy to maintain order. You just want to patch the hole to stop the repetitive manual labor.
What's fascinating here is that Ang's initial response was just that standard maintenance. The system was failing, and the human had to step in repeatedly. It's the psychological friction of this constant topping up.
The mental RAM it takes up is huge.
Exactly. You are fighting the natural degradation of the system. In any maintenance scenario, manual intervention is a sign of inefficiency.
You're just constantly reacting.
Right, but it's not just the kinetic energy of fetching the water. As you said, it's the cognitive load. You have a background process running in your brain at all times.
Like, did I check the pond level today?
Exactly. Is it going to drop below the filter intake? You aren't improving the system. You are just functioning as a biological life support mechanism for a failing container.
Wow, yeah. A biological life support.
Mm-hmm.
And most people would look at this leaking EPS box, get completely fed up with that cognitive drain, and either throw the box in the trash or drain the whole thing, dry it out, and just cover the crack with silicone.
Because you want to restore the boundary.
Here's where it gets really interesting, though. Ang is in the middle of this chore, literally in the act of pouring fresh water in to top up the pond, and has an epiphany.
A total shift in perspective.
Right. Ang envisions what the text calls an automated dripping system. Instead of patching the leak, Ang decides to utilize it.
Which flips the entire script.
It totally does. The bottom water will automatically drip out, and this entirely eliminates the need for manual water changes.
Right.
But wait, I have to stop and question the logic here.
Yeah.
They actually want their pond to leak? I mean, that sounds insane at first.
It does. This raises an important question about how we view closed systems, though.
It's like that tech concept of turning a bug into a feature.
Right.
Harnessing the exact thing that is going wrong and making it do the work for you.
That is the perfect analogy. And to understand why a leak is suddenly a feature, you have to look at the biology of what is actually happening inside that foam box. You have to understand the concept of bioload.
Right, because an aquarium or a pond isn't just a stagnant bucket of water.
No, not at all.
It's a living ecosystem, and, well, living things generate waste.
Exactly. Fish consume food, they produce physical waste, and they respire. All of this introduces ammonia into the water.
Which is highly toxic.
Incredibly toxic. So beneficial bacteria process that ammonia into nitrates and then eventually into nitrates.
Right.
But eventually, those nitrates just build up. They don't magically disappear. The only way to remove them from this artificial environment is to physically remove the old nitrate-heavy water and replace it with fresh, clean water.
You have to cycle the water.
That is the immutable law of keeping an aquatic ecosystem alive.
So wait, the chore isn't actually just adding water. The real chore is taking the dirty water out.
Yes, and look at the physics of the flaw Aang is dealing with. The leak is already doing the labor of removing the old water.
Gravity's doing the work.
Exactly. Aang realizes that the problem isn't the outflow itself. The problem is simply that the outflow is uncontrolled.
Wow. Okay, so if you can harness and control that outflow, you replace manual human labor with a natural physical force.
Precisely. You automate the hardest part of the maintenance simply by letting the flaw exist under controlled conditions.
You know, this heavily reminds me of how software developers approach resilience. There is this concept called chaos engineering.
Oh, yeah, like what Netflix does.
Exactly. Netflix famously pioneered it with a program called Chaos Monkey, where they intentionally inject failures into their own servers.
Just shutting things down at random.
Right. Breaking things on purpose to see how the system reacts.
Yeah.
It forces them to build automated recovery systems that are way stronger than the original rigid architecture.
Which is exactly what's happening here.
Yeah, Aang is essentially doing backyard physical chaos engineering. The leak broke the system, but it revealed a pathway to a much more resilient, self-sustaining architecture.
That is a brilliant parallel. Because in both cases, you stop fighting the environment and you start leveraging it. You take a destructive force and channel it into a productive mechanism.
But, I mean, taking a happy accident and turning it into a reliable mechanism is a massive leap.
It is.
It's one thing to have a cracked cooler. It's another to engineer a deliberate system. And this leads us to the mechanical solution Aang proposes in the journal entry.
Right, the transition from theory to reality.
Exactly. So Aang writes about installing a physical faucet directly into the bottom of the eps-foam box.
Which is a very specific, very deliberate design choice.
I have to push back on this, though. Putting a faucet at the very bottom of a container holding living animals seems, honestly, incredibly risky.
Oh, it introduces a massive point of failure.
Right. Because if you drill a hole into the side of a tank near the top and that valve fails, you only lose an inch of water. The fish survive.
True.
But if you drill a hole at the absolute lowest point of the floor and that gasket fails, your entire pond drains out in minutes. You're left with a dry foam box in total catastrophic failure. Why invite that level of risk?
Well, it is a valid concern, and it's the exact reason most commercially available aquariums do not come with pre-drilled bottom drains.
Because of the risk.
Exactly. However, from a systems engineering perspective, you mitigate that risk through redundant valve design. You'd use high-quality bulkheads and perhaps a double valve system.
Okay, so you build in safety nets.
Right. You accept the engineered risk because the physical payoff of the bottom location is just exponentially higher than a top or side drain.
Okay, explain the physics of that payoff for us. Why does the location of the leak matter so much? Why is the bottom so crucial?
It comes down to hydrostatic pressure and the biological reality of the waste we were just discussing. The text specifically contrasts this proposed bottom faucet with using a traditional siphon.
Oh man, anyone who has ever tried to drain a pool or a fish tank or even just a clogged sink knows the absolute misery of a siphon.
It's an awful chore.
It really is. You have this long plastic tube. You have to somehow suck the air out to create a vacuum.
Usually by inhaling on the tube.
Right. And you inevitably swallow a mouthful of dirty water. It's a messy, frustrating ordeal.
And why is it so frustrating? Because you are fighting gravity to start the process.
Oh, that makes sense.
A siphon requires you to apply manual kinetic energy to pull water up over the lip of the container before gravity can even take over and pull it down the other side of the tube.
You're working against natural physical forces from the jump.
Exactly. But a bottom tap relies entirely on hydrostatic pressure.
Meaning like the weight of the water itself?
Precisely. Imagine the water in that foam box as a solid column of weight pressing down on the floor.
Okay.
At the bottom, the pressure is at its absolute highest. You don't need to create a vacuum. You don't need to pull water up over a lip. The kinetic energy is already stored right there in the system.
Wow.
When you open a valve at the bottom, that hydrostatic pressure forces the water out instantly and powerfully.
So you turn a 20-minute, messy, frustrating physical struggle into literally just turning your wrist.
Yes. And mechanically, this addresses the specific nature of the bioload. Remember how Ang zeroes in on the phrase, especially the bottom waste in the text?
Right. Why does that matter?
Because organic debris like uneaten foods, solid fish waste, decaying plant matter, it does not remain suspended in the water column. It has mass.
Oh, so gravity naturally pulls it down. It sinks.
Exactly. It sinks to the bottom.
So if you just dip a bucket into the top of the pond to do your water change, you are pulling out the cleanest water in the system and leaving all the toxic sludge sitting right there on the floor.
Which is precisely why aquarists use siphons in the first place. They use the tube to act like an underwater vacuum cleaner, moving it along the floor to suck up that sunken debris.
Oh, I see.
But think about the inefficiency of that. A standard water change with a siphon is essentially like trying to clean a dusty floor by waving a fan around and just hoping the dust blows out a window.
That is a great way to picture. You're basically just stirring up a mess.
Exactly. But Ang's bottom faucet method, that is like installing a trapdoor right in the floorboards.
Oh, wow.
You don't need a vacuum at all. You just open the floor, and gravity sweeps the dirt straight down and out of the house. By putting a faucet there, Ang isn't just automating water removal. They're creating a highly efficient, localized waste management system.
It's a structural solution to a recurring chore.
Precisely. You have isolated the heaviest concentration of toxins and provided them a zero-resistance exit path.
That structural shift is just so elegant. You completely eliminate the behavioral chore of vacuuming by fundamentally altering the architecture of the environment itself. The floor does the cleaning for you.
And it highlights a principle of automation that we so often forget. Automation does not always require digital sensors or microchips or complex robotics.
Right, it doesn't have to be high-tech.
No, sometimes the most profound automation is purely mechanical. It's just arranging physical boundaries so that fundamental forces like gravity and fluid dynamics do the heavy lifting for you.
That's incredible. But, a theoretical faucet in a broken foam box is still just an idea. What really solidifies this journal entry is how Ang looks forward at the end.
Yes, the conclusion of the post.
Right. Before signing off with yours truly, Ang, until the next post, the text points directly to the future. Ang writes, and I'm quoting here, "Perhaps this is something we can explore for the planned new outdoor pond on the backyard balcony."
If we connect this to the bigger picture, this is an absolute masterclass in iterative design.
Iteration 1 being the EPS-foam box, obviously.
Right. It was a functional starting point, but it was flawed. However, that leak, that flaw, revealed a hidden mechanism.
And Iteration 2, the planned balcony pond, isn't just going to be a patched-up version of the foam box.
Not at all.
It's going to be a completely new paradigm built entirely around the lessons learned from that failure.
Because true innovation happens when you observe a flaw in Iteration 1 and intentionally engineer it into Iteration 2. In product development, you rarely build a flawless system on the first try.
Right.
The goal of version 1.0 is often just to see how it interacts with the real world. A lesser designer would have observed the leak, fixed it with silicone, and stayed permanently stuck on Iteration 1.
Just manually siphoning that box forever.
Exactly. But Ang formalized the failure. By incorporating the faucet into the balcony pond from the blueprint stage, Ang is ensuring that the ecosystem is self-draining by design.
And the context completely shifts there. The physical reality of water draining out of the bottom is exactly the same, but it transitions from being a frustrating leak to an automated environmental control.
Yeah.
Plus, when you move from a small cooler to an outdoor balcony pond, you are dealing with a totally different scale.
The scale is vital here. A balcony pond means a significantly larger volume of water, a much heavier bioload, and a proportionally massive increase in maintenance if you rely on manual labor.
Oh, absolutely. Siphoning 50 gallons is a chore. Siphoning 500 gallons, that's a part-time job.
It's exhausting.
Yeah, a physical workout you definitely do not want to do every Sunday.
Exactly. But here's the beauty of it. Hydrostatic pressure scales infinitely.
Wow.
The gravity pushing down on the bottom valve of a massive balcony pond works identically to the gravity in that little foam box.
Actually, it probably works even better, right?
It does, because the water column is heavier, which creates more pressure to forcefully expel the waste. By engineering the faucet into the new build, Ang ensures that as the physical size of the hobby scales up, the human labor required to maintain it remains completely flat.
It's just a brilliant extraction of wisdom from a totally mundane moment. I mean, a date in July 2026, a person noticing their cooler is dripping, and from that, We get this universal lesson in how to solve problems.
It really is profound.
The only variable that actually changed was the mindset of the person looking at the dripping water.
Which is arguably the most powerful tool any systems thinker can develop. The ability to look at a failure and ask, what is this breakdown teaching me about the natural forces at play?
Right.
Eng didn't invent gravity, and Eng certainly didn't invent the fact that biological waste has mass and sinks.
Right, those are just facts of the universe.
Exactly. But Eng recognized those properties when they presented themselves disguised as a problem.
We spend so much energy rushing to patch the broken things in our lives, desperately trying to get back to the baseline of how things used to be. And in doing that, we completely miss the chance to redesign the system so it's actually better than it ever was.
We fight the flow instead of directing it.
Yeah. The manual water change is a chore. The automated dripping system is an innovation. And it all originated from a defect.
It proves that if you can step back and detach yourself from the frustration of a failure, the environment will often just hand you the mechanics of the solution.
So what does this all mean? We have covered incredible ground today, from the system entropy of a dripping foam box to the biological realities of bottom waste, all the way to hydrostatic pressure and the iterative design of a self-draining balcony pond.
It is a remarkable amount of insight pulled from a very brief fish-keeping journal.
It really is. It serves as a great reminder to observe the world without immediate judgment. Sometimes a leak is just a leak, but sometimes it is the blueprint for automation.
Absolutely.
So as we wrap up today's deep dive, I want to leave you with something to consider in your own life. We've talked extensively about how a physical leak can be repurposed into a self-regulating system by attaching a faucet rather than applying a patch.
Because we all have our own metaphorical leaky eps-foam boxes, don't we?
We totally do. I want you to look at your own weekly routines, your workflows, or even just your household chores. What are the leaks in your week? Where are the recurring friction points where you constantly lose time or energy or resources just trying to maintain a baseline?
Those moments of endless topping up.
Exactly. Now, what if you stopped trying to aggressively patch those leaks? What if you leaned into the failure? Could that very point of friction actually become the engine for a fully automated, stress-free system if you simply found a way to attach a faucet and control the flow?
It's a powerful way to reframe your struggles.
It changes everything. When a system breaks, our first instinct is always to fix the hole. But maybe, just maybe, that hole is exactly what you need to finally perfect the entire design. Thank you so much for joining us on this deep dive.
It's been great.
It's always a privilege to explore these ideas with you. Keep looking for the hidden mechanics in your everyday failures, and we will catch you next time.